The next skill that we're going to work on is working with radicals. Now, there's way more that you can do with radicals. I just picked two of the radical skills that I felt like we should practice. The first one is how to simplify a radical, and then the second one is going to be how to rationalize a monomial denominator. This is the two things that will come up the most in this course. Simplifying radicals, what it is that if you have a number like 18, it's not simplified because there's a perfect square factor of 18. Just like, if you have a fraction 6 over 8, there's a common factor of 2, and they want you to take out that common factor. Here, what we're going to be doing is taking out perfect square factors. So there's a couple ways of simplifying radicals. The way that I prefer to do it is I like to draw two radicals, and then I look at the thing that's under the square root sign and I think, what's the highest perfect square that divides evenly into this number? So for example, 18 divided by 9 is 2. So I've broken the square root of 18 up into like a product of two radicals where one of them is a perfect square. And the reason I do this is because the square root of 9 is 3, and then I can leave it as 3 root 2. So it's a much simpler radical. So root 2 is simpler than root 18. If you don't like that method, I highly recommend looking different videos up on the internet, but you can do what's called a factoring tree. So we can divide 18 into its prime factors. So for example, 18 is 2 times 9, and then 9 is 3 times 3. And then what you can do is anytime you notice a pair, that's a perfect square. So 3 squared, the square root would be 3. So you could write the answer as 3 root 2. So up to you. The two methods are writing a product of two radicals and then trying to find the highest perfect square that divides into what's called the radicand, or you can do a prime factoring tree and then just pull out all of your perfect squares. Okay, so for this one I want to say pause the video, give this one a go, because this one can be a little bit tricky for people. So the reason this one's tricky is that if we look at our list of perfect squares, some people stop and they're like, hey, 9 divides in. And I'm like, yeah, sure, 9 divides in. You'd be left with 9 and 8. But 8 still has a factor of 4. So this one's tricky because if you go from the bottom up, you don't find the highest perfect square. You kind of want to do like take half of the number and then start from there and divide by perfect squares going down. So if you had done that, you would have recognized that 36 is the highest perfect square and you would get 6 root 2. Now if you had done it the other way and you got root 9, root 8, you would just keep going. Square root of 9 is 3, root 8 is root 4, root 2. This would give you 3 times 2 root 2, which would give you 6 root 2. So it gives you the same answer, and I don't care which one you do, but always try to find the highest perfect square that goes in. It'll just save you steps. If you had done the prime factoring tree, maybe you had done 2 and 36, maybe you stopped there and you're like, hey, wait a minute, 36 is a perfect square. Or you would go 2 and 18, 2 and 9, 3 and 3. So then you would look like that, and so you would go, the square root of 2 squared is 2. The square root of 3 squared is 3. So you'd have 2 times 3 is 6, and then you'd have a perfect radical, or a radical left over. You'd have 6 root 2. All right, try 240. 49, 64. So what I always do is you'll have maybe you'll write yourself a list of perfect squares. 81, 100, 121, and 144. So I'm going to take half of 240, which is 120, and then start dividing. So I would do 240. Does it divide by 81? Nope. 240. Does that divide by 64? Nope. 240 divided by 49? Nope. 240 divided by 36? 240 divided by 25? 240 divided by 16. There we go. So root 16, remainder root 15, which would give you 4 root 15. And again, you could do the prime factoring tree so you don't have to sit there and go divided by, divided by, divided by. You get to just do it, right? You're like, ooh, 240, 2 and 120, 2 and 60, 2 and 30, 2 and 15, 3 and 5. And then you look for pairs. So 2 and 2, 2 and 2. That gives me a 4 out front with a root 15 behind. All right, if there's already a number out front, just leave it there. So you would just do the same process. So for 56, we're looking for the highest perfect square that divides evenly into 56. And I'm having a brain fart what it is. 56 divided by 4. There we go. So 4 and 14. So you'd end up with 2 times 2, root 14, which would give you 4 root 14. And then same thing with this one. Keep the 3 out front and just do the root 32. So again, this one 4 divides in and so does 16. So 16 is the highest perfect square. So you can end up with 3 times 4 root 2, which would give you 12 root 2. And again, like I was saying before, feel free to do the factoring trees if you like them. They are like a surefire way of getting there versus a guessing way. And that is simplifying radicals.